Okay, so we worked a little bit with Excel, and now let's try MATLAB. When you're performing simple calculations, you might not really be able to differentiate between why you would want to go through the extra learning curve of learning how to use MATLAB. But as we continue to work a little bit with these programs, you will see the advantage of learning how to use MATLAB. Now, when you first open MATLAB, you will get your window. You might see the command window in the middle, current folder window on the left-hand side. So you'll see, for example, if I move forward, I've got some of my most recent files that I've created here. And then on the right-hand side, I see my workspace. And in my workspace, I see all of the parameters and the functions and the arrays that I have defined in some previous actions that I took. So we can clear all, and you'll see that if I hit clear all, then my workspace is cleared. If I have things in my command window, then I can clear, and then CLC, and CLC will clear my command window. So as you saw, I can perform simple calculations, but obviously that's not why you would want to use MATLAB. I can actually plot the cosine or sine function here. So how do I set that up? I have to set up an array of values. So t equals from 0 with a step size of 1 to a maximum value of 6. If you remember, that's how we started off in our Excel example. And so t equals 0, 1, 2, 3, 4, 5, 6. If I don't put a semicolon at the end of my command, then I can actually see the results show up underneath. So for example, if I had said t equals 0 with a step size of 1 and a maximum of 6, and I had put a semicolon, then nothing would have shown up on my command window. Then I can actually put FREQ equals 1. I won't use semicolons so that you can actually see these values being set. But in fact, if you go over here, you can actually see the value of the frequency and see the values of your array elements. What else do I want to say? I want mag equals 10. So we'll match the last example. So I'm putting the semicolon because you know where to look for the magnitude. Magnitude equals 10. You can see it show up in your workspace here. And so now my function equals mag times cosine. Let's do sine this time. Sine of 2 times pi. Note that unlike Excel, MATLAB does not need this open close parenthesis to define pi, times FREQ times t. And there you have f. And I can double click on this and actually see the values of f. And note that even though this looks like it's a finite value, it's actually times 10 to the minus 14. So you might not quite get a 0 value, but pay attention to the exponents. Okay, so now I need to plot t comma f. And there I have it. Now this looks like a straight line, but again, look at the scale, 10 to the minus 14, and it's really a very small scale. So this is not going, say, from 0 to 1. So let's actually look at axes properties. And then just go to more properties, and we can look at the x scale is fine, but if you look here, I can find the y scale. So I have to go down. Here's my y scale. The y limit mode is automatic, and I want to set it to manual. And so now my y limits are, let me open this up a little bit. So I want my y limits to be, let's say, 0 to 1. And so let me close this out. And so you see now that the sinusoid, obviously sinusoid 2 pi times n is equal to 0. So you've got a solid blue line right at 0. And you can see it because now I fixed my y scale. My y scale was basically going from one very, very small number to another very small number. So it looked like you had some variation in your values, which is not true. So I'm going to delete this. I'm going to X out of it, because this is not really where you want to be working. You don't want to be working in your command window, because now when you want to change the frequency or the time scale, you have to do it all over again. So what you really want to do is create a script. So you're going to go over here and hit New Script, and now you've got a script window. So this is great. If you remember, we in the beginning just cleared everything. And so if I just type these two and hit Run, first it's going to ask me to save it. And I'm going to save it as example 1. Okay, now you see it's named example 1 up here in the tab. And what it did after I ran it is it actually cleared out my command window and cleared out my workspace over here. So you really want to, when you write commands, to either go inline, hit the % sign, and you see it turns green. And so clear all sort of clears the MATLAB workspace and everything. Now CLC clears the command window. And then if you want, F close all. Actually will close any open files. Okay. So now I'm going to set up the program to ask for the amplitude of the sine function, the frequency, and the initial phase of the sine function. Okay, so you have to be, you want to write comments, but you need to be, you know, short and sweet. So AN equals input single quotes, what is the amplitude? And you see the minute I closed the quotes, everything turned purple. And so I sort of know that I've done something right. Let's see what happens with this command. So I'm going to run. And you see down here in the command window, what is the amplitude? And when I put in the amplitude 10, it's sort of stuck right next to this, and it's hard to read. So in fact, inside these quotes, you can just add spaces. And you can even put like mag equals and all of that stuff. So if I run it now, then mag equals 10, and so your command window shows you everything. Of course, I'm not doing anything with mag, so that's the end of the program. And then I want to say FREQ equals input, what is the frequency? And we've learned that there are at least 2 units of frequency, so I'm going to say in hertz. Okay, so FREQ equals and space. And then phi naught, we didn't use this in Excel, but I'm going to use it here, input of what is the initial phase in rads. And phi naught equals, oops, okay, so now I've got 3 parameters I can play with. The amplitude, the frequency, and phi naught. And let's just say, because I'm using mag and I've used it all over the place, I'll use mag here. And so now what do? Now I have to set up the time array. And we already know that 0 with a step size of 1 won't work. We haven't really talked about the parameter called the period of the sine or the cosine. The period of the sine or the cosine period equals 1 over frequency, where f is in hertz. And hertz equals 1 over second, so capital T is 1 over f. So what I'm going to do here is say period equals 1 over FREQ. Now what that means is that I now know how much time, what the repetition time of my function is. So I have an idea of how long I want. So let's say I want to plot a max time which is equal to 2 times the period. So now I'm actually setting up my problem to, whenever I change my frequency, my graph will automatically adjust itself to plot 2 times the period, and you'll see how that works. So now I'm setting up my time. T is equal to 0, and now I want to do a step size that is a ratio of my period, and let's say I want 100 points within one period, so then I can actually do period divided by 100, and then I want to add to max time. Now I can do it in here, which is great, or I can do time step equals period divided by 100, and then here I can replace this with time step. And all I have to do now is calculate the function. And so f equals mag times sine of 2 times pi times FREQ times t plus phi naught. And then plot the function. So that's plot t comma f. And I'm done. So what do I do now? I run. What is the amplitude? 10. What is the frequency? Let's say 1. What is the initial phase in radians? Let's say 0 as an initial example. And here is my plot. Now, so you see the sinusoid starts from 0, goes to maximum of 10, and I've plotted 2 periods. Let's change the period. Let's see if what I said is true. So I'm going to run this again. What is the amplitude? 10. What is the frequency in hertz? 1. No, let's say 2. What is the initial phase in rads? 0. Now notice that I didn't get a plot here because I already have a graph up. So let me look at my window, and now I want to go to my figure, and here's my figure here. And this time, see, it plotted 2 frequency values again. If you want it to always pop up, then just X out of it and then run again. Let's go home to editor. I'm running. What is the amplitude? 10. What is the frequency? 2. And what is the initial phase? 0. And it pops up. Now with a frequency of 2, 1 period is 0.5, so you see that it has automatically adjusted the time over which it will run. With 100 points between for each period, then I have a nice smooth line. But essentially with all of these programs, with Excel, with MATLAB, with any program that you're going to use, you have to discretize your parameters. In other words, you're not going to have a continuous time t. You have to sample t, and then your programs essentially draw straight lines between your points. And so the higher sample or the finer steps you take, the better your results will be. And so that's how you plot the cosine. Now let's try one other example. Let's try one more thing. I can put hold on. That means that my figure will stay on. If you notice that when I plotted when I ran each time, it would initialize my figure and it would each time plot a different function. So what happens if I don't do that? If I run this once, 10, let's say 2 and 0, then I get this figure 1. Okay, that's great. Now let's run it again. This time let's do 10, 2, and let's say phi equals 1. So that would be that 1 rad. And let's go up here and find the figure. And you notice now that I have 2 figures on here. One is the initial one that I drew, and then the other one is the one with the phase shift. And so in the second instance, the phase was ahead by 1 rads, and so it started plotting as if that rotating radius, if you remember from the previous examples, was already at 1 rad, and so it would start from a value of about 8.5. So again, all of the known things, I can edit this. I can edit figure properties. I can double click on this. I can actually scroll down and change my limits. So this is another way to do this. Or I can pull this up, and now I have a nice view of the y limits. If I want the x-axis limits, then I go to the x-axis. Say I want only 1 period, so I'm going to take it to 0.5. And now I only have 1 period. I can go here and select the line, and I can make it thicker. Here you've got lines of the same color, so if you want to differentiate the colors, then you can choose red, but in a thicker line. But if you also want to differ, if you have to print in black and white, or if somebody's colorblind and you're just using colors to differentiate between 2 things, then that's not going to work, and so maybe you need to actually use different kinds of lines. And this doesn't look very different, so let's try this one. So sometimes depending on how it's discretized, and then you might want to put markers, but in this instance you don't want to, because they're just, you see, with your discretization you've got markers all through. So generally we have no markers in this case.